Hello there, fellow coders. Welcome to Chapter 5 Quick Study Guide on Looping. Please like, subscribe and hit the notification bell. Whether you're just starting out or you've got some experience under your belt, understanding loops is crucial for writing efficient and effective code. First off, what exactly are loops? The structure that allows you to write one set of instructions that operates on multiple separate sets of data is the loop. They help automate repetitive tasks, making our code cleaner and more efficient. The loop that frequently appears in a program's mainline logic uses the same logic as any other structured loop. You do not set a loop control variable equal to a sentinel during each loop iteration. If you did, the loop would never repeat. The statements within a loop compose the loop's body. A counter is used in a program to keep track of the number of times an event has occurred. Adding one to a variable is also called incrementing it. A loop that executes a specific number of times is a definite loop. A loop that asks the user whether to continue is an indefinite loop. It keeps running a block of code as long as a specified condition remains true. When two loops are nested, the loop that is contained by the other is the inner loop. When loops are nested, the outer loop starts, then the inner loop starts, then the inner loop ends, and finally, the outer loop ends. It is convenient to use a for loop when a programmer knows the number of repetitions a loop will make. This is perfect for situations where you know the exact number of iterations you need. Let's say you want to iterate over a list of items. You'd use a for loop to go through each item one by one until you've processed the entire list. A report that lists only totals and no details about individual records is a summary report. And finally, we have the do-while loop. This one is a bit different because it guarantees that the code block runs at least once before checking the condition. This is useful when you need to ensure a block of code executes before any condition is evaluated. For instance, you might use a do-while loop to ensure user input is checked before deciding whether to continue or stop. Now let's touch on some best practices for using loops. First, always ensure your loop has a clear and reachable exit condition. An infinite loop can crash your program or cause it to hang indefinitely. Second, try to keep your loops as simple and readable as possible. Complex nested loops can make your code hard to understand and maintain. A counter variable most often is incremented by 1. Typically, a different value is added to an accumulator on each iteration. After an accumulator or counter is displayed at the end of a program, there is no need to adjust its value. Validating data ensures that data items are the correct type and within an acceptable range for the application. Forcing a value is overriding its current value to set it to a predetermined value. A variable might always hold an incorrect value. A do-while loop is a type of structured post-test loop whose body always executes at least once, but it can be replaced by a sequence and a while loop. Whether you're automating repetitive tasks or iterating over data structures, loops are essential tools in your coding arsenal. Keep practicing and you'll unlock the true power of loops in no time. To see more videos like this, please click in the rectangle in the middle of your screen. To see other videos from this channel, please click the circle on the bottom right. Don't forget to like, subscribe and hit the bell icon for more programming tips and tutorials. Catch you in the next one.